A database is the digital container where your information lives. But to actually manage and query that container, you need specialized software called a database management system, or DBMS. Look at this overloaded spreadsheet. When you pile all your data into one massive file, you get duplicated entries and a tangled mess. The relational model solves this by fracturing that data into distinct, clean tables, connected by specific relationship lines. To build our own system, open the Windows search menu and select the MySQL 8.0 command line client. As you can see in this diagram, we start by typing Create Database Company. Then we type Use Company. This opens up a fresh, empty container ready to hold our tables. Establishing this environment is the first step in moving beyond static files and building a system where data stays organized and interconnected. Before we add any data, we have to build the permanent architecture. We do this using Data Definition Language, or DDL. We will begin by creating our first parent table to hold our company's departments. Here, the Create Table Departments command executes. Notice the primary key syntax. This constraint gives each row a unique identifier, preventing data confusion. By adding auto-increment, the database automatically generates these IDs sequentially as new rows are added. With the structure set, we shift from Data Definition Language to Data Manipulation Language, or DML. DML is what we use to populate the architecture we just built. Watch the table populate as we run the Insert into Departments command. We assign the values HR and IT, and the database automatically assigns them to ID 1 and ID 2. The operational rule here is clear. DDL commands build the house and are automatically saved as permanent structures, while DML commands put the furniture inside. Next, we need an employees table to hold our staff records, but this table must directly relate back to the departments we just created. On the right of this split-screen diagram, a physical line connects the dept ID in both tables. This bridge is built using the foreign key constraint. It ensures an employee's department corresponds exactly to a valid ID in the parent table. If you attempt to assign an employee to a department ID that doesn't exist, like ID 99, the database will immediately throw a red error and block the action. Pause the video here and try it yourself. Write the SQL insert statement to add an employee named John O, earning a salary of $50,000 into the IT department. Here's the solution. We use insert into employees with the values John Doe, 50,000, and the number 2, tracing directly back to the IT department. By enforcing these relational constraints, the database blocks invalid entries and prevents orphan data from cluttering your tables, keeping the link between records intact. To confirm John Doe was successfully added, we retrieve the records by running a basic select statement on the employees table. To modify existing data, look at this update command executing. We set the salary to $55,000 where the name is John Doe, and you can see the specific cell flash and update in real time. Remember, unlike those permanent structural DDL commands, data manipulation actions like update can often be rolled back to the previous state in a transactional system if you make a mistake. Let's review this cheat sheet. We've separated our operations into DDL commands for building structure, DML commands for handling the actual data, and the strict constraints that link everything together safely. Mastering these structural rules gives you the foundational tools to connect different datasets and maintain a reliable relational system as your project